Hey students, it's Dr. B, quick and dirty stats. It's the 23 Dominicans data and extra practice for practical exam questions. And we are looking at question 5. Using our new grouping variable, which we made in question 3, let's graph the fast scores, but by group. Okay, so let's get JASP. So a minute ago, there's the data. A minute ago, we looked at the FAST scores by raw, and then we looked at the FAST scores by percent because it was easier to tell our story. And then we looked at them in box plots. But so the question was, now let's look at them by group. And well, we can keep the raw and the percent in there just for the exercise. You really wouldn't use both or need both, but it's only electrons that we're inconveniencing. Now we're going to group them. So let's group them. We're not grouping them by their age now or their length of residence or their age of arrival. We're grouping them by 12 or over is a 1. That's our grouping variable. So we're going to use that for a split. Nice. And we can get the distribution plots, the pie charts, that was just for a joke, and the box plots. And if we're getting the box plots, let's get the violin. Yeah, why not? Because it's just fun to say violin. Okay, so here it is showing us the two groups. So the group 0 is the younger group, and the group 1 is the older group. Now remember, the raw and the percent, they're really the same data. It's just that we've converted it to percent because we like to work in percents, right? Because thinking about it as a student, making an exam worth 100 makes sense in my brain. Okay, so for the young arrivers, their scores ranged from 74 to 96, the 0 group. And for the older arrivers, their scores ranged from 53 to 87. So it does seem like the late arrivers did worse on our fast task. I say the word sit positively, I say the word sit positively, right? Okay. 468 times. You can be sure I paid them to take the experiment. Okay, so here are the fast raw score for the 0 group. See the little 0 over here? Oops, that's not what I meant to do. I was just trying to point that 0 out to you. Okay, so they did, like we said, from 348 to 452, but we'd rather see it. And here are the group 1s, the late arrivers, from 200 to 450, so scoring much lower, the bulk of them scoring here. Here it is in percents. The early arrivers, the 0 group, under 12, right? Because we made over 12 was equal to 1. Always have to check ourselves before we wreck ourselves. And 70 to 100% for the early arrivers, and 50 to 90% for the late arrivers. And we have the bulk of them in the 60 zone, whereas here we have much more in the 90 to 95, 85 to 95 zone. So yeah, it seems like the early arrivers as a group did better than the late arrivers as a group. Here they are in violin plots. The violin overspersed over the box plot. That's pretty trippy looking. So, but you can see, here it is in the percent version. Obviously the graphs are the same shape. It's just the axis is whether the axis is raw or percents. So here you can see that the young ones, not only did the young ones do better, but they had a much tighter, as a group, they did a lot better. It was just a tighter range. The older ones really ranged. That violin business, we don't really need that. Okay, so this leads us to our next question. Do I have it in here? Wait a minute. Using our new grouping variable, let's see if the two groups performed differently on the FAST score. Okay, so let's roll right into question 6. So we're actually doing question 5 and 6 together. I better write that down for the videos. Question 5 and 6 together. So in good statistical behavior, I said, let me look at the groups first. And when I looked at the groups, I said, well, the young group is from 70 to 100. The old group is from 50 to 90. And where the humps are seem to be in different places. And if I look at it in a box plot, forgetting what the violin business included or don't include the violin, they really do look different. So I should do a statistical test on this. So moving to the next question, question 6. I have 23 people. How many in each group? Wait, let's go back up top. 14 in the younger group, 9 in the older group, right? 14 young arrivers, 9 older arrivers. Those groups are not big enough for parametric statistics, right? You can look. First of all, they're a little bit different in size. They're different. They're so small that the difference in size is kind of big, right? The difference between if we had 104 and 114 and 109, we wouldn't care. But 14 and 9, and all told, we have 23. Splitting 23 into two groups, we have to use non-parametric statistics. It's a little cheap to even do it, but we're doing it anyway. So when we have two groups, the young group and the old group of arrivals, we need to use a t-test, right? T-test, T for 2, T for 2, and 2 for T. I don't know, you figure out a way to remember it. Okay, so here we're going to go here, and look, it has a box plot with 2 things in it to help you remember. ANOVA has a box plot with 3 things in it to help you remember. So t-test, let's go by the t-tests. Oh, this thing is in my way. T-tests. So independent samples, paired samples, one sample. Well, we know we have 2 things. We've got the young ones and the old ones. Are they paired? No. Either you're a young one or you're an old one. No, I should say either you arrived at under 12 or you arrived at over 12. But this is how it's happening in my brain. You're seeing it as it goes. Okay, so it's got to be independent samples. Either you're in the younger arriving group or you're in the older arriving group. So it's an independent samples t-test. Same question, right? How'd they do on the FAST score? And our group is 12 or over is a 1. We cannot use student t-test. We're going to use Mann-Whitney U. Get rid of student t-test. And we're going to leave the hypothesis as group 1 not equal to group 2. But really, our hypothesis is actually that group 2, who's the young ones? The young ones are group 1, the zeros. So we're just going to leave it this way. But our hypothesis is that the young arrivers are better than the old arrivers. But we're just going to leave it as unequal for now. It's more conservative. If we have to deal with that later, we'll deal with that. Assumption checks, we're not going to bother with. Okay. Let's get the descriptives just because we want to see them looking the same. And let's get plots. No, we don't want descriptive plots. There's somewhere here where we can get more graphs. Well, meanwhile, we already have a graph and we can shut off that stupid violin if we want to. Okay. So they call it an independent samples t-test, and then here it says, note, Mann-Whitney U. So what you report is they call it a W. I always was taught to call it a U. U equals 117.0. P less than 0.001. So P less than 0.001, converting that to money, we know we were going for a nickel. This is way smaller than a nickel, right? A nickel is 0.05. So that means 5 in 100. 0.001 is 1 in 1,000. So that is much smaller than 5 in 100. So here are our means and our standard errors. So you can see the mean on the young ones was 410.5, and the means on the older ones was 317. Same data we had. It better be the same result, right? The means with the split data. Oh, here's the split data. Okay. There it is. The means were 410.5 and 317. That better be the same. And the group size 14 and 9 better be the same. A little obsessive checking. A little obsessive checking is okay. A lot of obsessive checking, not so much. So you would use this graph, turn off the violins. Let's turn off the violins. They're just confusing, I think. Go back up here to descriptive statistics. Turn off the violin. And so you could use the histograms, change the axes to all go from 50 to 100, force them. Or you could just show this. I think this is very telling. It's very easy to see here. And you can just use a text box or whatever. You can just, obviously you're going to make this more pretty so that it doesn't say fast_raw 468, right? You're going to prettify it, but there are your boxes. And it's pretty obvious that the young group is having a higher achievement than the older arrivers, right? The people who came at 2 and 5 and 7 and 9 are doing much better than the people who came when they were teenagers and in their 20s. On this task, hearing the final consonant bump up against the initial consonant. Okay, and there it is in percent. Same data, but in percent. Okay, so you've got your graph, and then on your graph, you just put Mann-Whitney U equals 117, comma, P less than 0.001. Okay, awesome. That is question 5 and 6. And I am going to stop my recording.